Alrighty, we are going to be starting to work on probably the most important concept, at least in the first semester of Algebra 1, which is called slope-intercept form. We've already been doing this, and you've already done this before, but we just didn't know what it was called, and we haven't used it the way we're going to be using it today. Alrighty, slope-intercept form is always known in this form, and you guys will get to hear me sing the song tomorrow about this. I know you are really excited, but for now I need you to write this into your notes. The y and the x are going to stay, but the m represents slope, and I don't know why they picked the letter m, but they did. And the b is going to be the y-intercept. Okay, and the y-intercept is where x equals 0. So those are the two things we need to know, and pretty soon you'll be able to graph lines, in about 10 to 15 seconds, but it will take a while. So finding the slope and the y-intercept, in order to do that, we need it into that y equals mx plus b form, which means when we learned how to do function form back earlier in this chapter, there actually was a reason to it. Now, when I look at this problem, I want to do Ann's method and put a 1 there. So I am going to try to get the y by itself right away. And to do that, I need to get the 2x by itself, or the 2x, sorry, to the other side. Now we know that these are apples and oranges. It can't be combined. So I'm going to get negative 1y. This is why I write the x first. It's because this form. So I go negative 2x minus 3. You still can put the x second, but it's definitely easier to put it first. Then I have to do the heart method to get it by itself. So I get y equals, whoa, don't do that. Y equals positive 2x plus 3. Because negative divided by negative is positive, negative divided by negative is positive. Now, it is in y equals mx plus b form. Whoop. Let's get this up here. So I have to figure out what the m value is and what the b value is. Okay, well, the m is the slope right here, which is 2, or written as a fraction is 2 over 1. And the b value is right there, that's 3, or even better, I would prefer you to write the b value as an ordered pair, 0, 3. Meaning, on our graph, this is where we start. Okay, b is the starting value. And then we use the slope to find another ordered pair. Okay? So if we're graphing in slope-intercept form, we have to once again get it into y by itself, or function form. So I subtract the 3x. And I get y equals negative 3x plus 2. Well, I'm lucky there's nothing in front of the x, so we're done. We have to identify the m and the b value. Well, the m value is the thing in front of the x, so it's negative 3, or negative 3 divided by 1. And the b value is 2, or the ordered pair, stop that, computer, or the ordered pair 0, 2. Now, in order to graph it, I take the b value, the starting value, and I graph that first. So I go 0, and I go up 2, and there's my point. It's on the y-axis because it's the y-intercept value. And now I'm going to take the slope, and I know that this is rise over run. So I'm going to rise negative 3 from here, not from there, from here. So I'm going to go down 1, 2, 3, and I'm going to run 1. Positive 1's this direction, so I'm right there. Now, you could do this again from this point 1, 2, 3, 1 if you wanted to, but you don't have to. And now, because we have more than one point, we can graph a line through these. And now, instead of making those long, drawn-out tables of values, I graphed a line with just slope-intercept form. And there, that's our whole line. Okay, so I'm going to copy this over. Oh, I guess I already did that. I'm on top of it. I would like you to try this one on your own. I think I want to learn how to write pause in a foreign language so I can write it. Like el pause. I don't speak Spanish, obviously. For this one, you didn't have to write it in function form. It was already done for you. So you could do m and the b. Your m value is negative 2 over 3. And that's rise over run. and your B value is 2, or the ordered pair 0, comma 2. So I'm going to go 0, 2, so that's my B value right there. And now I do my slope, so I'm going to rise negative 2 from here, 1, 2, down, and I'm going to run 1, 2, 3 over. I could do that again if I wanted to, 1, 2, and then 1, 2, 3. And what's really cool about this is that because it goes down 2, right 2, if I wanted to go backwards, I could go left 3, up 2. Just do the exact reverse, and then I can make an even longer line if I wanted to. And now to graph it, I'm just through there. Make sure I put my arrows on it, and I'm done. That's all there is to it. Alrighty, parallel lines are one of the things in this section that'll be added. And the thing about parallel lines are they're two lines that run even with each other, like this. And what we need to know is with these two lines, they will have the same slope. Okay, so if two lines are parallel, it means that they have the same slope. If they have the same slope and the same B value or y-intercept, then they're the same line. Okay, because everything about them is the same. But if they have the same slope, we know they're at least parallel. So when it asks the question, let me check to see if we have another slide. If it asks the question, are these lines parallel? What it wants you to do is figure out if they have the same slope. So for this line up here, the m is 3. And for this line here, the m is 2. So no, they're not parallel. And I never spell parallel right. I think it's right there. Okay, for this one down here, we obviously have to turn this into function form first. This one we don't, but I would like you to try that on your own. Okay, I'm going to move this one over. And so here I'm going to subtract 2x from both sides because I'm trying to get y by itself. So I get 2y equals negative 2x plus 4. And I'm going to divide by 2 and do the heart method. So I get y equals negative 1x plus 2. So my m is negative 1. Over here, my m is, using Ann's method, positive 1. And so no, these are not parallel. Quick story problem. A company makes decorated hats. No one knows why they would do that, but they do. They decide they can make money. And the data suggests that they have a linear model of y equals 1.9x plus 350. X is the number of hats, while y is the monthly cost. Graph the model and use it to estimate the cost of 35 hats. Well, you don't have to graph it, and I'm not going to require you to, but I do want you to use this model to estimate the cost of the hats. And the way we do that is we take out all the non-important information. We don't care about that. We don't care about that. But we do care about our equation, and we do care about that x is number of hats, and y is the monthly cost. Okay, so x is hats, and we want to know 35 of them. So we take our equation, go y equals 1.9 times our 35. Why did I do 3.5? I have no idea. 35 plus 350. And I just multiply that out. $416.50. And that's our answer. And that also coincidentally is why we're learning this model, because a lot of stuff is done in a linear fashion in the real world. Tons and tons of stuff. Alrighty, tomorrow for a grade, or if you're watching this video in class, I would like you to do these two problems. I would like you to graph the top one, and I would like you to tell me if the bottom lines are parallel and why. And that's for a grade. See you tomorrow.